Hi everyone, today I'm going to introduce two types of the principle of chromatography and their examples. So the first type is partition and the second type is adsorption. Noted that the adsorption is ADSORP but not the word absorb. So it's this one, not this one. So what is their difference? This adsorption means the adhesion of the solid molecule. So the solid molecule, let's say this is the solid molecules, and they are adhesive, so they will try to attach to the liquid surface due to the surface forces. So this is known as adsorption. They will attach to the surface on the liquid due to the surface forces. Partition is the principle of partition is the difference in solubility. So we know that a compound, it will consist a polar part and a non-polar part, right? So this is the polar part, say, and this could be a non-polar part. And both of them will have different solubility in mobile phase and stationary phase, and that will differentiate their component or separate them into different solvent. They will dissolve in the different solvent, mobile phase or stationary phase. While on the other hand, adsorption is when a solid molecule, as I said just now, and they are adhesive to the liquid surface, so they will attach or stick to the liquid surface, and hence the other part of the molecules, so for example non-polar part, will go through or move through the mobile phase. So this liquid is stationary phase. Stationary phase basically means a phase that does not move, and mobile phase basically means a phase that is moving. So when a molecules dissolve or is being carried by the mobile phase, it will move faster than the stationary phase. Now let's move on to some examples of adsorption and partition chromatography method. So I will introduce the first one. So I will introduce adsorption first, as it only contains one example, which is the thin layer chromatography. So as I said, each and every separation technique would have their mobile phase and stationary phase, so that the molecules can undergo adsorption or partition, right? So in this thin layer chromatography, the mobile phase will be non-polar and stationary phase will be polar. So what is the example of non-polar? So anything and particularly organic solvent like ethanol, right, or mixture. So what are the examples of polar? So usually we'll use silica or aluminium coating. And when a molecule, it consists polar and non-polar, right? So when it consists of polar, so this non-polar will move through the mobile phase, and this polar will be stuck at the stationary phase, and therefore we'll see on the chromatogram, which give us a shorter retention time of the non-polar. Because it is mobile phase, it will move through the detector first. Now let's talk about some examples of partition. So the first example is paper chromatography, and the stationary phase, I use S for abbreviation, and the mobile phase would be polar and non-polar. So what are the examples? Organic solvent and mixtures. In this paper chromatography, the polar stationary phase is a bit unique, which is the H2O bounded layer. So the water is stationary, it won't move due to some advanced technology. So it's known as the H2O bounded layer. Now HPLC, we have normal and reverse phase. So in normal phase, the stationary phase would be polar, and the mobile phase would be non-polar. So polar, you can use silica. But for reverse phase, everything is reversed. That means the stationary phase will be non-polar, and the mobile phase will be polar. And the nonpolar and polar is actually customized. Nonpolar will use silica that is coated with octane or C18 carbon long chain, while polar will use water with methanol or water with ACN. Gas liquid chromatography is similar with the reverse HPLC. Stationary phase will use nonpolar, while mobile phase will use polar. And we'll use inner gas, and this inner gas actually act as a carrier gas, so it will not react with the particles, the sample. And the nonpolar, we can use non-volatile liquid that coated into inert particles. So because in this particular GLC, we'll use heat to vaporize the sample. So for stationary phase, we don't want it to be vaporized as well, because it will be no point, right? So we will use non-volatile liquid. That means this liquid will be very high boiling point and coating to inner particles, so that the stationary phase will not react with the sample and will not vaporize into gas.